So today we're going to look at kind of a standalone lesson on data representation. That's just basically when we collect data and then we show that data in some sort of format, maybe a graph, maybe a chart, something like that. Okay, it is the most difficult statistics you would ever do with elementary. Okay, I mean it's called statistics, but don't let that freak you out. It's not like upper level at all. But we need to know some things. The first thing is we need to know whether or not we're going to put in our graph or our table one of two types of data, or sometimes a combination of both. So we can have information or data that is qualitative, or information or data that is qualitative. Okay, quantitative, I'm going to do this definition first. These are categories that are numerical in nature. So it could be percentages, it could be grades on a test, it could be, heartbeats per minute or something. Anything where the value is a number. Okay, and then the qualitative data is any non-number category. So it could be like favorite candy or color or, boys, girls, gender, or something like that. Okay, so we're going to look at some different ways that we can show data that we gather, have our students begin to learn how to show the data as well. And probably the most basic formats are these three right here: bar graphs, line graphs, and pie charts. Okay. There's also some maybe less known ones, but I want you to know these as well. Okay. A histogram is very similar to a bar graph. You do need to know the difference though. The difference is the x-axis is always quantitative data, whereas a bar graph could be quantitative or qualitative. And usually represents ranges of values. So I'm going to give you an example of all of these. Okay. Also, the bars don't have spacing, whereas in a bar graph usually you separate the bars with gaps. Okay, we're going to look at a scatter plot. And then we're going to look at a frequency distribution. That sounds really fancy. It's actually not at all. It is a great way for us to tally information. So usually a frequency distribution is in table form, not necessarily a graph. And it just keeps a tally of the number of times that each item occurs. So we're going to do an example of those in just a little bit. But often we'll get a frequency distribution and then we'll transfer that data into maybe a bar graph, line graph, pie chart, something like that. Okay, so I'm going to take these really in no specific order. So I want to show you a scatter plot first. So here's what a scatter plot might be. Okay, so let's say I wanted to show the speed of a bike over time. So first thing is always make sure that you have some sort of label on your graph or chart. Okay, so let's say that we were doing a scatter plot. So a scatter plot is going to have a horizontal and a vertical axis. Okay, so I'm going to just set up this, and you can kind of sketch this as well. So we're going to make the horizontal axis the time in minutes. And then we're going to make the vertical axis the speed. So I'm going to count by 2. And so we're also going to label the vertical axis. So let's say that the vertical axis is speed in miles per hour. And so a scatter plot would be for you to actually, if you were the person riding the bike, you would record your speed at various times, okay? So if the scatter plot looked like this, so kind of like it says, a scatter plot is scattered. Okay? So what's being shown in this scatter plot? Obviously the bike speeds up for a time, and then what does it do about right here? It starts slowing down, and notice here we're pretty much back at a stop, right? Okay, so in other words, in 20 minutes, it looks like about their bike ride. Okay, let's include a few more dots here. Okay, so he started riding at 0, right, and he rode for a while, got to a maximum speed of about maybe 6.57 miles per hour. Okay. So let's talk about what scatter plots are good for. Scatter plots are good for noticing highs and lows, increases or decreases. So they're good for seeing patterns like that. They're also good for when rates are not constant. So notice this person's not just riding their bike and, you know, staying at a constant speed. They're actually speeding up, okay, and then they slow down and stop eventually. Okay, so let's look at, we're going to look at all the other 4, or sorry, actually 5, data representation devices with the same set of data. So let's say that this is a list of test grades. So I'm going to list quite a few test grades here because I want to really show how what the point of these tables and charts are. So it'd be like a teacher looked down at their grade book and this was the grades for exams. Notice they're not in numeric order, so they're really in no particular order here. Okay, so as you write those down, just make sure that you have 22 total grades. Then you'll know you didn't forget any. Okay, if not, you'll want to pause the video and find the one you missed. Let me make sure I have 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 22. I think I said 22, but let me count again. Okay, I can't count, which is kind of a problem for a math teacher, right? So there are 21 grades. I just miscounted the first time. All right, so first we're going to show a frequency distribution. And we're going to show a frequency distribution for the grades, like the letter grades. So we're going to go A, B, C, D, and F. Even though, by the way, at the elementary level and really junior high and high school, there probably isn't such a thing as a D. Okay, but we're going to go with it anyway. All right, so this is what a frequency distribution. So you would do something like title it letter grades. Okay, and then you just come up with a table. And then we're just going to keep a running total through the use of tally marks as we go through our list of grades, okay, and keep a running total of how many of each grade we have. So just start with 76. Notice that's a C. The next one's 80. That's a B, right? 78's another C. So kind of finish this off, and then we'll compare our numbers at the end. Notice I'm kind of pointing them out as I go so that I don't forget one. When you get to 5, you do 5 in this way, okay? Okay, so I think I got them all, but notice we could do a quick count and make sure that we actually got them. In other words, how many different tally marks should I have? Of course, I should have 21, right? So notice here I have 3, right? Here I have 7, that's a total of 10. And then here I have 11, so it looks like I counted all my 21 grades. Okay, so this is all a frequency distribution is. Okay, you show with tally marks. Notice we didn't actually have any D's and F's on this chart, right? So the frequency distribution can show 0 items. So let's talk about some benefits for a frequency distribution. Okay, frequency distributions are really easy to read. They're really easy to create as well. Okay, I think most of our elementary students could do a tally count like that. So I'm going to say they're very simple to create and read. They're often, I already mentioned this, but I want to write it down. They're often used in addition to other graphs. In other words, a lot of times we're going to turn this information into, like, say, a pie chart or a line graph or something like that. And notice it can show items with a count of 0. Some of our data representation tools won't be able to do that. Okay, so notice it summarizes all of that long list of numbers, right? If you just give me this list of numbers, I'd kind of get lost in those, right? So this gives me a sort of summary of those. Okay, so let's look at, we'll just kind of go in no particular order here. So let's show a bar graph. And then I'm going to show you a histogram kind of right after that so you can kind of see the difference. So for a bar graph, we're going to do the letter grades. So for a bar graph, we would need at least this. You can make a box if you want, okay? But we're going to put the grade down here, and then we're going to put the frequency that grade occurs here. Okay, you could also call it the grade count or something like that. It really doesn't matter. And so I am going to only list A's, B's, and C's. Notice I'm not going to list D's and F's because I don't even have any values there. Okay. And then I need to at least go to 11, right? So you want to pick a scale that's appropriate, but you also may not have to count by ones. So notice I'm choosing to count by 2s just to make it easier on myself. But then what I like to do if I count by 2s is just, even if I'm not going to number them, I go in there and stick a point in between. So I have 3 A's. Now when you make a bar graph, notice we center the bar around the value here. Okay. So there are 3 A's, right? There are 7, so maybe about right here-ish. My lines aren't particularly straight. And then there were 11 C's, so I need to go pretty high for that one. So in a perfect world, these would be the same width, and they would be straight, but it is what it is. Okay, so notice this shows the same information of this just in bar form, right? All right, so let's talk about some benefits of the bar graph. Okay, one benefit is that it works with many types of data. Okay, it works with both qualitative and quantitative data. I think they're fairly easy to create and read. You know, if you had younger students that you were worried about them being able to draw, you could always kind of draw the vertical and horizontal axes for them and then just have them do the bars as they go. Okay. I've also seen students or teachers use like little Post-it notes and let them stack the Post-it notes and it'll make a bar. Okay, so that can be helpful. Notice that it doesn't show items with a count of 0. In other words, we didn't even put the D's and F's. So I'm not saying that that's necessarily a fault. it's just something to notice, right? If we wanted to list all the possibilities, even the ones that didn't end up showing up in our data collection, then bar graphs don't typically show that. Okay, so I want to compare this with a histogram. Now, go back and look at the definition for histogram. Notice that our horizontal axis has to be quantitative. Notice my horizontal axis right now is not quantitative. Okay, so what we would have to do instead is we would have to just alter this just a little bit. So we're not going to show letter grades, but maybe we could show just grades. Okay, so this is maybe how we could do this. So we're going to show grades between 80 and 90 and between, sorry, I need to start with 70, right? So forget I said that. 70, 80, 90, and 100. Because I think we can agree that the grades can stay contained there, right? Okay, so we'll just, instead of saying letter grades, we'll label this axis as grades. And then we'll still have frequency up here. So I'm still going to count by twos. Okay, so the difference here would be that I have how many grades kind of in between 70 and 80. Notice I have 3 grades. So let me go back to my horizontal or vertical axis and put in the marks. Okay, so notice the difference here is rather than centering, we're going to do the bar all the way from 70 to 80. Okay, so these are the grades that are 70 to 80, 3 of them, right? And then the grades that are 80 to 90, there are 7 of those, right? So I might have made that bar a little high, but it's close enough. So this is 80 to 90. And then last but not least, I have 90 to 100. Okay, so notice the difference. The bars are not separated by space, and then we're really doing ranges of values, right? So this is the range from 90 to 100. Okay, so that's typically what you're going to see in a histogram versus a bar graph, okay? But they're pretty similar, right? Okay, so let's just talk about a little bit about histograms. We've already kind of mentioned a few of them. So I'm going to say data must be quantitative. Numbers, in other words. And usually ranges. I'm going to say usually in ranges. Okay. Other than that, I don't really have a whole lot to say about the histograms. They're similar to the bar graphs in most aspects, okay, other than the 2 things that I just mentioned. Okay, now let's show a pie chart. So a pie chart, right, is going to look like a circle. We're still going to label that. So we could say test grades, we could say letter grades, however we want. So first you'll have a circle, right? And then whatever the percentages are will take up a piece of that pie, right? So we have some work to do off to the side. We need to talk about how many A's we had, how many B's we had, and how many C's we had. Okay, but not only that, we need to talk about them relative to how many total test grades we have, right? So notice 3 out of the 21 scores were A's, and if you divide that out on your calculator and move the decimal place twice, that's about 14.29%. Okay, this is 7 out of 21. Okay, use your fraction reduction, right? That would be 1/3. So this comes out to be 33 1/3%, since that's what 1/3 represents. And then last but not least, 11 out of 21 if you work that out on your calculator, would be 52.38%. So notice one thing that you might notice here is the percentages aren't necessarily pleasant in this problem that I picked, right? So if I were going to teach pie graphs, I might purposely pick data that worked a little bit better. So notice, I'm going to start with my A's. Okay, my A's were, not my A's, I'm sorry, my biggest category. So I'm going to start with my C's, which was 52.38%. Okay, notice it's easiest to start with things that are close to benchmark percentages, right? Which 52% was just a little bit more than 50%, so that's why I chose that one. 33 1/3% is exactly a third. So I'm going to use kind of a different color here. So try to do about a third of the circle, right? So the B's, that would be 33 1/3%. Notice I'm putting the percentage on the pie chart. That's usually what you'll see. And then last but not least, we have the A's, which are 14.29%. Okay, notice these aren't perfect, and I'm not really looking for perfection, but I would expect something that's around 50% to look like it was about half the pie. Okay, so let's talk about pie charts. I don't think I have to tell you that it might be difficult for students to create a pie graph, right? So I think we can say they're very easy to read. In other words, if it's already done for them, I think our students won't have trouble with that, but it can be difficult to create and certainly to accurately show certain percentages like the one we just looked at. So I'll say it can be difficult to accurately show certain percentages or portion sizes. So if I were going to have my students create pie charts, I might pick data that was pleasant, like maybe some that worked out to be like 50%, 25%, things that I think they could easily split the circle up into. Okay, some other benefits, just like the bar graph, it works with many types of data. Okay, you can use quantitative data. Notice we didn't, right? We used qualitative data. Similar to the bar graph, it also doesn't show items with a count of 0. So I'm going to say items with a 0 count here. And then last but not least, honestly, this might not be information we would actually show in real life as a line graph, but it's worth talking about anyway. Okay, so let's show a line graph. So again, we're going to say either grades or letter grades or test grades. I think I changed the title throughout there, but it really isn't. The title isn't important other than the fact that I want you to have one. Okay. All right, so let's look at a line graph. So let's go back to A's, B's, and C's. Only the histogram did we absolutely have to change. So 0, 2, 4, 6, 8, 10, and 12. So in a line graph, you just put a point at the individual values. So notice there were 3 A's, right? There were 7 B's, and then there were 11 C's. Okay, and then you connect them with line segments. Okay, they don't necessarily, it won't be one solid line, it's more like connect the dots kind of thing. So in my opinion, this data actually doesn't really make a whole lot of sense to draw as a line graph, but I didn't want to introduce to you all kinds of data. Okay, all right, so let's talk about the downfalls of line graphs. Maybe not the downfalls, but the qualities of line graphs. I don't really know why I said downfalls. So this really works best for quantitative data. Notice that's not what we had here. And more than that, it works best when showing maybe values over time. That being said, they are easy to create and read, right? It didn't take us that long. If you don't use it in the right context, it can be confusing in between items. And that's why it works best showing values over time. In other words, what does this area in between A and B represent, right? That's why I'm saying maybe a line graph isn't actually the best way to show this data, okay? One thing that it can do that the others haven't really been able to do, it can show items with a zero count, right? So if I wanted to, I actually could include D and F in this chart, right? It's just that those values would be down here. But even more so, do you see how the line graph maybe isn't the best representation, right? Because really, this isn't showing values over time, right? These are just strict counts. Okay. So these are all different ways to show data in your classroom. To be honest, it's great if you can get your students to participate in this data. So what I've done with some of my students before is, like, I've taken a survey and said, like, what's your favorite Halloween candy, or what's your favorite Valentine candy, or what's your favorite color, and then have the students vote on those things and then have them tally it up, have them put it in a pie graph, have them put it in a bar graph. There's something about students gathering their own data that can be helpful. But I'll just give kind of a disclaimer. You'll want to control that a little bit. For instance, you need to think ahead. Let's just use a for instance. If you had 17 people in your class, well, if you're going to divide everything by 17 on your pie chart, that's going to make things a little challenging. Okay, so in that scenario, if I had, for instance, 17 students, if I were the teacher, I would probably vote myself, because 18 is a much more pleasant number to work with than 17. Okay, so that's just something to think about. So have them create their own data. That can be awesome, but you'll want to have an active involvement in that too.